of last time. 3.1. So in this section, we learned this derivative of power functions and exponential functions. So this, as we have been discussed last time, can be proved by induction. So we guessed the formula. Guessed a formula. To verify this, the proof by induction, so mathematical induction. Okay. And this is one of the problem on the homework. Have you checked? Okay. And the more general case, for this one, we say is for integer powers. More generally, a minus 1. Hello, Skinner. So for any a, let me check Elisa. And this will be proved later. We also learned the derivative of the exponential function. Zichen, what do you say about this derivative? E to the x. Try to remember, try to refresh your memory. Okay, it's okay. In a few weeks, you will remember this. Okay. This is a very special function. The derivative is itself. That's why we call this the natural exponential function. Too special. The derivative is itself. And slightly more general for a positive base, I use B. Exponential function. Again, so this will be proved later. First, we have the formula, then we will see how to prove this. Okay. Then the next section, we introduce the product rule. It's about the derivative of the products. The product of two functions is a new function. So the derivative is a little bit complicated. Sometimes with the short notation. So the short notation is f g derivative f derivative g f g derivative. Okay, that means the same thing. And then we have to emphasize that derivative of the product is not the product of derivative. Fg not. And a simple example to keep this in your mind, to remember this is x3, x5 derivative will be x8 derivative. but with 3 derivatives, 5 derivative is 3x2. They are very different. Okay. And we will give a very short argument. Oh, at least I did here. Okay, why? Okay, how to get this formula? It's not difficult. Let's give a quick argument. Okay, how do we prove the formula? What would you do? Definition. We go back to the definition. We don't have much tools at the moment. So these are very basic formulas. So we go back to the definition. Definition of the derivative is we compare the increment from x to x plus h to the increment of the product. We manipulate the increment. So the first term is a derivative of f. So we insert a term with the difference of f. So insert a term and copy g. And here we insert one, so we add one back. We have fx. And we copy the term fx dx. Okay, so we subtract one, then add it back, so we have the equality. Now, these two terms, gx plus h, x plus h is the common term. So we can pull out this fx plus h. Second term, f, can pull out this f. So to find the derivative, we divide all of them by the increment. By h, divide by h. We divide this by h, divide this by h. Okay, so Sakina, now you can see from here, if we take a limit, we will get the derivative of the product, right? Because that's the increment, take a ratio, take a limit, get the definition. What's the limit of this one when h equal to 0? So this is the f increment, the difference over h. Not 0. So here, that's how we define the derivative of f. Is that right? So that's how we define the derivative. So this one goes to f derivative. This when h equal to 0, just goes to gx. We add fx. This one, again, when h equals 0, the derivative of this. So this goes to the definition of the derivative. So that's how we get to this product rule. We start with the derivative of the product. we end with the summation of the derivative of first one, second, first, derivative of second one. That's the product rule. And it's not the product of the derivative. That's the key point. Okay, let's try another example. We want to find the derivative of let's apply the product rule, see what you get. For those on Zoom, but enter your answer on chat. I can check. Okay. So here we apply the product rule. This will be our f, this will be g. There will be f derivative g, f g derivative. So f is x derivative e to the x, copy f ex derivative. Now we know the derivative of this is 1 e to the x, x e to the x. So e to the x is the common factor. We can see this will be 1 plus x e to the x. Okay, so that's the first derivative. Now let's go one step further. Okay, let me add a few more pages. 3, 4, 5, 6, 7. Okay, go back to our page. One more step. Let's find the second derivative. X e to the x, second derivative. So then how do we do second derivative of the first? So the second derivative is the derivative of the first. First step. Okay, for the first one, we copy the result from the first step. 1 plus x e to the x. Okay, now again, it's the product of two functions. Let's apply the product rule to find the derivative again. Again, that on Zoom, enter answer in the chat. Let's see what you have. Okay, so the derivative of the sum will be the sum of the derivative. What's the derivative of 1? 0, because it's a constant. The derivative of x, 1. Okay, so this will be just 1. Okay, so again, we apply. Okay, yes. Okay. The product rule, it will be the derivative of the first part. Copy the second function. Copy the first function. Derivative of the second part. So the derivative of this polynomial, so it will be the 0 plus 1 e to the x, copy e to plus x. Derivative of exponential is just the, okay, just e to the x. Now we can combine them. 1 plus x to be 2 plus x e to the x. Okay, so we start with this function. The first derivative, we get 1 plus x. Second derivative, we get 2 plus x e to the x. Now let's one more step. What's the third derivative? Okay, that's the result, but let's try to check the steps. So you know the result, but there's a few in the steps. Third derivative. Okay, so Kendall, how do we find the third derivative? Okay, very nice. Yes, exactly. So it will be the derivative of the second. So we can copy the second derivative from the previous step. One more step. Okay, let's see what the result will be. Few in a step, don't jump. At the beginning, I want you to write the details of each step. And after we are familiar with then we can jump steps. But initially, we just take every step. The product rule. Many of you are working, so let me start. First function, derivative, copy second. Copy first, derivative of second. Oops. Derivative of 2 is 0. Derivative of x is 1 e to the x. 2 plus x is still e to the x. Now we have another one, 3 plus x to the x. Okay. Okay, so Sophia has been working. Now, Elisa, I want you to guess what's the formula if we take 100th derivative?
100 plus x e to the x.
Okay, so that's right. 100 plus x e to the x. So this is the formula. How do you get this formula? Do we take all the derivatives or do we have other approach? So then what would you do? So use proof by induction. So proof by induction. Okay, Sophia, do you know this proof by induction, Sophia?
Yes.
Okay, let's try. So in this case, how do we formulate? How do we proceed? Give me a brief description. Don't have to be perfect.
Um. So. Um.
Okay, so let me refresh your memory. So there's a proof by induction. We first have the basic case.
This case, yeah.
The base case, in this case, is n equal to 1. The base case. N equals 1 x e to the x derivative 1 plus x. Okay, this is just the product rule. Very easy, we have done
Yeah.
it. Then the next step is the induction step.
You have to do like K
Okay. So n equals
for
k.
any number K. It has, if it works for K, it works for K plus 1.
Okay, yes. So what does this mean? This means we assume this formula is true for n equals k. So that's the assumption. X k equals k plus x. We want to derive the next case. The next case will be x to the k. I'm sorry, got lost. Okay, plus 1. K and the k to k plus 1 and k plus 1. So this induction step is built on the previous case and aim at the next case. So why is this helpful? So we have checked one holds, the 2 also holds. Then we know 2 holds, the 3 also hold true. 3 to 4, 4 to 5, 5. So step by step, this covers all the cases. Okay, so now Zichen, we know the case K, how to go to the K plus 1 derivative. How do we move from here to there? If we know the 100, how do we go to 101? You take one more derivative. So to go from this K to K plus 1, we take one more derivative. Okay, so let me write down the steps. It's not difficult, but you have to go through it one time. X e to the x, so the k plus 1. This is x e to the x, k, and the derivative again. We want to take k plus 1's derivative. We take the k's first, one more, so k plus 1. This one, by the induction, we know what it is, so we plug in. So this is the induction. This step is just the power rule. Okay, so this will be 0 plus 1, x. Again, last time, just summarize. It will be k plus 1. Okay. So in this step is the hypothesis. And the last step is what we want to. We finish this induction process from k to k plus 1. Now you can see, okay, we verified it for any n is true for 100, so we have this formula. So Kina, have you seen this before? No, the induction. Okay, it's not difficult. You just follow the steps. The base case induction step. Induction step, from this a small step. Okay. So the next one, where we'll learn this, the quotient rule, the product rule, the quotient rule. Again, it's very useful, but it can be confusing. I will use a short notation. F, G, the derivative of the quotient of two functions. Maybe Sophia, you know the formula, Sophia. What's the formula?
It's g of x times the derivative of f of x minus f of x times the derivative of g of x over g squared.
Okay, yes. Okay, again, we will prove this formula. Looks complicated, but let's start with a special case. Special case when 1 over g, what's the special case? Oops, what's this? Okay, Zichen, now I replace f by a constant 1. What happens to the formula? So this f is 1, what's the derivative? 0, it goes away. F is 1, g derivative, just one term left. This is very easy. So it will be negative 1 times g derivative. Okay, let's try to prove this. Okay, I asked you before, now ask you again. How do we prove this? What tool do we have?
Definition.
The definition or something. I got it. The definition. Okay, let's go back to the definition. The definition of the derivative, so we compare the increment. So what's the increment? From x to x plus h. Okay, so the increment, 1 over g at x, 1 over g at x plus h. Okay, so common denominator. Common denominator, h dx. So the first one, okay, Sakina. For the first one, if I put this common denominator, what do we get on the numerator? Gx. So the second one is x h. Okay, that's easy. Okay. So to put this into the familiar form, I'm going to pull out a negative sign, then I will switch the two. So this is -1. Nothing strange, just the very basic algebra. Then I divide all of them by h. Divide the whole thing by h, divide by h, divided by h. Okay, Sakina, I asked you before. Now if I take a limit of h equal to 0, what does this lead to? The derivative is yes. So this will go to the derivative. Now go to the derivative. What about this? If I take a limit of this one, where does it go to? Against the derivative. This one, if I go to limit, go to -1 over gx, when h equal to 0. Now, so this is the formula. the derivative of the reciprocal is negative the square and the derivative. Okay, so we have verified a special case. We will use this to check the general case. How to check this? We see it's a quotient rule, but it's the product rule for the reciprocal. Okay, let's try. So I'm going to zoom out a little bit. F G derivative, I claim, is the product. Do you agree? Okay, now we can apply. I will give you a few minutes to apply the product rule to the product with the reciprocal. See what you get. See if you can get the formula yourself. Use the product rule for the reciprocal. Check your progress. Let's use parentheses to emphasize it's the derivative of the reciprocal. Parentheses. Okay, yes. Okay, now let's apply the previous special case. We have found the derivative of 1 over g. Apply that formula. Okay, so we are making progress. Let me catch up. This will be the derivative of the product. Okay, product rule. The derivative of first, copy second. First function, derivative of second. Now, so this is just f prime over g. And this f, the formula, negative derivative g squared. Now we will put them into common denominator. This one denominator g squared g, we will multiply the first one by g. So we get common denominator g squared f g minus g. So this is the quotient rule. Okay, let's have some application. Let's find the derivative of the quotient. We'll start with derivative of x squared, derivative of and the quotient. Okay, 3 steps. Derivative of the numerator, derivative of the denominator, so then let's work. And the derivative of the quotient. Lisa and Sophia, enter the answer in the chat when you finish. The derivative of x squared minus Zichen, what's the first one? Okay, so let's go to the formula. I will be back. So the formula we started with xn will be n x minus 1. So what's the result? Yes, yes. Okay, so this one is 2x. So Kina, what's the second one? 3x squared. Okay, now we have both. Let's apply the formula, see what the quotient rule give us. It's a little bit long. So apply the formula. On the denominator is the square of the denominator. It will be x. Okay, on the numerator, the first will be the derivative of f. I don't do anything. I just plug in the formula. Copy the denominator. Copy g. Subtract. I copy f. Don't do anything. Just copy. Copy g derivative. See, I don't do anything. I just copy. Okay, Sakina, let's continue. So x cubed plus 5. What do you say the first one? 2x, then I copy. The second one. Very nice. I don't need to burn. Okay, that's good. Okay, so now we can simplify this a little bit. See what we get. X. This will be 2x 4 10x minus 3x 4 3x squared. So okay, very complicated for result, but we get it step by step. Okay, let's try another one. This time I'm going to try e to the x cubed plus 4. Okay, apply the quotient rule. Don't jump steps. At the beginning, copy everything of the formula. After you master the formula, then you can skip a few steps. Well, okay, you skipped one. It's correct. Okay, so I'm going to follow the formula. The formula is g squared f derivative g f g derivative. In this formula, g is x cubed plus 4. F is e to the x. F is e to the x cubed plus 4. Even I know what it is, but still I copy the formula. So I want you to follow my model. This is e to the x 3x squared. I'll simplify a little bit. E to the x common factor. Okay, let me check. So Sophia, you missed the 4 in the first term, right, Sophia? Should be x cubed plus 4.
Oh,
The first term.
yeah, I saw.
Okay, cool. Okay. Any questions from both of you? Okay, so this is about 3.2. So the next section, we will take a derivative of trigonometric functions. So let's have a break. After the break, we move to 3.3 derivatives. Of trig function. Okay, we'll be back at the 47. Okay, so this section is very important because for trig functions, based on my experience in college, teaching college, many students get confused about these trig functions. So we will spend a lot of more time on the details about taking derivatives of the trig functions. I want to know where the formula comes from. Not only the formula, but how you can derive this. For that purpose, we'll start with two very basic formulas. Two very basic formulas. Okay. For the first formula, the limit sine theta over theta when theta goes to 0 is 1. Second formula, limit when theta goes to 0, cosine theta minus 1, the difference over theta is 0. Okay, so we will prove the first one. For this one, it's a two-side limit, but because sine is an odd function, this is also odd function. The positive or negative, it has the same formula. So we only need to check the one-side limit. Okay. So the difference, because if theta is negative, sine negative theta, this is the same thing. If the limit on one side is 1, the other side is also 1. So we only need to check this, because if we see that it's positive, we have the geometry, we have the triangle. So what we know about this is sine is theta. Okay, we start with this. Okay, let's see how to verify this. So here we assume, what is this? Let me draw a picture. Not good. Okay, so now we consider a arc of radius 1. One circular arc. If this angle is the theta, it means that this arc, the length of this arc is theta. Okay, that's the definition. So we go to this theta, and this sine theta. And tangent theta is this. So because if we look at this right triangle, 1 theta to sine theta. If we look at this right triangle, this is 1, this is the theta, this will be tangent theta. Because of this relation, we can say this is longer than this. So this one is shortest, medium, longest. So that's why sine theta less than theta, theta less than tangent theta. Sakina, do you agree? Okay, and Elisa, do you agree with this?
Yeah.
Okay, so now with this, I'm going to rewrite this inequality slightly different. Slightly different. For the first one, if I divide both sides by theta, keep in mind theta is positive. We have the same inequality. Okay, so the first one, I get sine theta over theta less than 1. Do you agree? Okay. Sophia, do you agree with this one? So I divide both sides by theta, I get this inequality.
Yeah.
Okay, now this one, I'm going to write this as theta less than sine theta over cosine theta. What I'm going to do, I'm going to divide both sides by theta. Because it's positive, so we get the same inequality. And because the cosine theta is positive, I can multiply opposite both sides by theta. By cosine theta, I get the same inequality. So in this process, I use the assumption theta between 0 and pi over 2. Okay. Now we have two inequalities. I'm going to put them together. Put them together, I get cosine theta less than sine theta. Okay, I will check with everyone. Zichen, any question about this one? No, because this one is the first part, this one is the second part. I just put them together. Sakina, agree? And Elisa, agree?
Yeah.
Okay, so Sophia, so this is very elementary, but it's so important that I want to emphasize, I want to check with every one of you. Now we do something we do in our class. We take a limit. So this one, when theta goes to 0, limit is 1 because it's constant. Okay, Sakina, what's the limit of this when theta goes to 0? Cosine 0, what's that? Cosine 0 is 1. All right. Okay, now we have the squid theorem. This one go to 1. This one also go to 1. This thing in between, it has to be 1. So by the squid theorem, here have to, this is the one-sided limit because we have used the property repeatedly. Okay. From the one-sided limit, and we have get into over there, the other side has the same limit. So the two sides coincide. Limit. They are the same. So because if we replace this by negative, sine is an odd function, negative theta. Negative theta is positive. Let me put a few more details about this because this may not be that straightforward in the beginning. The reason for this argument is if I multiply both numerator and the denominator by the negative sign, it stays the same. This limit sine, because sine is an odd function. Now, theta is negative theta is positive. This follows from the previous limit. Okay, the two limits coincide, so we conclude the two-side limit, two-side limit is 1. Okay, that's the first one, very big step. Okay, the next one, we move to cosine. So for this, we use one identity that you are very familiar with. I'm pretty sure you are very familiar with. So cosine theta, let me check. Okay, Zicheng, what's this? Okay, so you know this, very nice. So from there, we conclude 1 minus s. I will subtract cosine square from both sides. Sine square, 1 minus cosine square. Okay, Sakina. So here I can write this as the difference of the two squares. There's a formula for this. For the difference of the two squares. So what's the formula? Okay, okay. So it will be the product of the difference with the summation. Okay, that's all we need for the second formula. Now we are ready to prove the second formula. Let me cosine theta minus 1 over theta. For convenience, I'm going to put out a negative sign. This will be limit theta to 0, 1 minus cosine theta. Do you agree with this? I just made up a negative sign and switch this. Okay, that's easy. Then I will, here we have 1 minus, I'm going to multiply the conjugate part. On the numerator, we have the product of the difference with the summation is the this is sine squared. That's what we have been prepared for. It's not easy, so I will divide this, partition this into two parts. Sine theta over theta. Sine theta 1 plus cosine theta. Now let's check. Sophia, what's the limit of this first part when theta goes to 0?
One.
Okay, we have 1. So this one, and use different color, goes to 1. And Elisa, what's the limit of the second part?
One.
Oh, sorry. You said one. I got carried away for the second part. It's 1. Sorry. Okay, the second one. Okay, Elisa, second one. When theta goes to 0, what's the sine 0? Okay, Sakina, what do you see? And the cosine 0. Okay, so now we get 0, 1 plus 1. So this 1 times 0 is 0. Okay, so now we have the two limits. Okay. Limit of this goes to 1, limit of this goes to 0. Okay, so this, we can reformulate these two limits in terms of the derivatives. Okay, for the first one, fx sine x. Now, what's the derivative at 0? Okay, what's the definition? Okay, it's a check. The derivative of a function at 0. Limit something. So there are two definitions for the derivative, a general function. What's this? It will be f a plus h f a. Okay, let's try this definition. In this definition, we applied it to this function at 0. It's a what do we have? What's the limit? It's still the same. H equal to 0. H. So f is sine a is 0. What's fa? Sine 0 is 0. Okay, so this is sine 0. Fa plus h. Sine 0 plus h. Okay, we know what this is. Sine h over h. Okay, so okay, now what's the limit? 1. Okay. So what we just checked tells us the derivative of a sine function at 0 is 1. Another one, gx cosine x g0. Okay, Sophia, I want you to say what's the limit, what definition of this using what's the definition of this?
Plus h goes to 0 cosine of x plus h minus cosine of x over a.
Okay, so that definition, and we add 0 to cosine 0 cosine 0 plus h. And then later we'll go to x. At the moment, just this one point. Limit h go to 0 cosine h minus 1 over h. Okay, Zichen, what's the limit? It's not in the screen. If I move it a little bit. Okay, so we have done that part. We have done that part. You can compare this with the one we had over there. It's the same thing. So 1 times this is 0. Now, if we look at the graph of the functions, what's the graph of sine? Try to graph this on your note. Graph of sine. So sine 1, -1. Sine function. So the first formula tells us the slope of the graph at 0 is 1. Okay, over there, the slope is 1. Now let's cosine. The second formula tells us the derivative at the cosine over here is 0. Slope is 0. Okay, the matches what we saw on the graph. For sine, the slope is positive. This is 0. Okay, next we'll go to the general case. Fx equals sine x. We want to find the derivative function. Let's just use sine. Okay, Sophia, what's the formula for this one?
Sine x plus h minus sine of x over h.
Okay, very nice. Now see, how do we take a limit? And this involves one of the formula we had at the very beginning. Let's try to recall that formula. sine alpha beta. The formula for angle addition. Okay. Do you remember that one? Formula for angle addition. Okay, okay, yes, yes. Sine alpha cosine beta. Alpha. Okay, so the angle addition, we will apply this formula the first term. Limit equal to 0. Little bit long. So h. Formula for angle addition. Sine x cosine h cosine x sine h minus sine x. Now we are going pairing. We will split this into two parts. I will put these two terms together. For these two terms, sine x will be cosine h minus 1. Oops. That's neat. Okay, nothing fancy, just the basic algebraic manipulation. And I will check. Zichen, this part is independent of h, so it will be fixed. What's the limit of this one when h equals to 0? Okay, now we have this part go to sine x times 0. And Sakina, cosine x did the same. What's the limit of this part when h equals to 0? Sine h over h. Okay, so this goes to sine x times 1. So the limit is the summation, and this is cosine x. Okay, so we found that the derivative of sine x is actually cosine x. Did it be strange? Now let's move to the next one. We want to find the derivative of cosine x. To save some space, let me move this one over there. Next one, gx cosine x and the derivative of cosine x. Okay, I will give you a few minutes to try to work out the details. What's the definition? Use the definition, and you will need the formula for angle addition for cosine. So what's the formula for cosine? Oops. Sophia, how do you group these three terms? Which is yes.
U factor cosine HL.
Yeah, so this two has cosine, so it will be cosine h minus 1. Okay, now we want to find out what's the limit. Elisa, okay, Sophia, okay, you are still here. Okay, Sophia, what's the limit of first one? Cosine stay the same. Limit of this
0.
0, nice. Minus sine x stay the same. What's the limit of this?
0.
Oh, double check.
1.
Okay, yes. You made the same mistake I made before, so now we are even. Okay, so you can see this not easy, but with the definition and this formula, angle addition and subtraction, angle addition for sine and cosine, we find the derivatives of the sine and cosine. So as we have mentioned before, these two formulas are the fundamental formulas for the trig functions. Many of the properties of it are derived from them. Okay, now let's formulate, put them together. So our summarization is derivative of sine x equals cosine x. Derivative of cosine x is negative sine x. Okay, very nice. Now let's go a little bit further. Let me check with you. Enter your answer in the chat or write it down. What's the second derivative of sine x? Second derivative of cosine x. So how do we find the second derivative? Sophia and Elisa, enter your answer in the chat. Steps. Okay, that's the step. Okay. So the second derivative. Okay, I have Sophia over there. And the Skinner, let me check. Yes, that's the correct setup. Okay. So the second derivative is the derivative of the first derivative. Sine. Again, I will go to the steps. You don't want this. I do it. For this one, we change the formula. It's a cosine x. Derivative of cosine, negative sine. Derivative of first derivative. Negative sine x. Negative cosine x. Okay, easy. Yes, that's correct, Sophia. One more step. Find the third derivative of sine and cosine. Sine x third, cosine x third. And the fourth, sine x fourth, cosine x 4, and you know where this is going. I want to go to 100. What is sine x 100 cosine x 100. Could be difficult, could be easy, depends on how you view it. The last part of today's lecture. Correct. Okay, so this again will be the derivative of the second derivative. Elisa, do the work. Elisa. And enter your answer in the chat when you are done. Okay, so cosine, what's the second derivative? This is second derivative, right? It will be the derivative of the second. So copy this negative cosine, and the whole thing plus the derivative. What's this? So cosine, where is the formula for cosine? Okay, over there. Cosine is a negative sign. So this will be negative of a negative sign. Uh-huh. Okay. Yes. And the fourth derivative. Fourth. Okay. Now now let's make some observation of the fourth before we move to the 100. Okay. Third will be the derivative of the second. The second is negative sign, Sakina. So this is negative sine x derivative, negative cosine x. Cosine, negative cosine derivative, negative sine x. Fourth will be derivative of the third. Derivative of the third is negative cosine x, negative sine x equals sine x. Derivative of third sine x cosine x. Okay, some observation. What happened if we take the fourth derivative? Sakina, sine function fourth derivative. We will go back to sine again. Cosine x fourth derivative. We go back to cosine. Fourth derivative, now what about the eighth? Sine, cosine, 12. So 100. Yes, so we go around in the circle 1 time, 2 times, 3 times, 25 times of fourth derivative. So we go back to sine x, cosine x. Okay, normally if we will do this hand by hand, okay, it will take a while, but we make observation. For this sine and the cosine, we do it 4 times. We recover the initial function. So every 4 times we recover the function. It's 100. If you go to 1000, it's the same thing. What about 101? That will be 102. So this 101 will be 101. Okay. So now you see what this is going. Okay, one more step, we are done. Sine x, if we go one more step. Oh, sorry. One more step. This will be sine 101 cosine x 101 cosine 101. Okay, so we will have more about this next time. And on Friday is a holiday. Do you have plans? Or let me give me 1 minute. Let me stop recording.